we now have two strategies that we can use to solve inequalities. Okay, so in quadratic inequalities in particular, we can find our boundaries, and again, it's very important that we establish that the boundary or equal to 0 is the key point here. Once we find the boundary, what we did initially was we just tested the boundaries. Okay, so we just plugged in numbers into the boundaries, the boundary areas, to determine which part of the boundaries, which part of that number line represents the solution. So that last example, the 2 and -2 represent our boundary. We have this region here. We have 3 boundary regions that we could test. Okay, so that's one strategy. The other strategy then is to graph. Okay, and sometimes we don't have the option to graph. Sometimes we don't know what the graph looks like, and we don't have a graphing tool. But if we know what the graph looks like, even without a graphing tool, we can solve this using the graph. And the graphing strategy looks like this. What we want to look for is where the graph crosses the x-axis, and depending on whether we're looking for above or below, okay, we can see which portion of the graph is above or below and select our solution bounds by that above or below strategy. Okay, so we have a testing strategy, we have a graphing strategy. We also need to be able to solve this by algebraic strategies as well. So we're going to have 3 different methods that we can go to when we solve these quadratic inequalities. But the algebraic strategy is going to be, again, dependent on the key idea of where the 0 is. But we also have this one other wrinkle with inequalities is when do we flip the inequality sign? Okay, so we have to make sure we know when to flip the inequality sign. So if I add 2 to both sides, will this make my inequality flip? Well, no, that's not going to affect the inequality at all. If I subtract, 8, this is going to be -3. This is going to be -5. Well, this is still going to be lighter than that. So subtraction doesn't flip the inequality. If I double this side, so times by 2, times by 2, okay, 10 is still bigger than 6, so that doesn't flip the inequality. The only thing that flips the inequality is if we multiply or divide by a negative. So if I multiply by -3, that's -15. If I multiply by -3, that's -9. Well, -15 is lighter than -9, so that's going to flip the inequality in that direction. And we have to flip the sign. So when we multiply or divide by a negative, we need to flip the inequality sign. So inequality sign changes. We shall say flips when we multiply or divide by a negative. Okay, so what is the algebraic solution then going to look like when I solve this? Okay, so we have